Hello, Algebra 1 CP students. Hopefully you're having a great day so far. You may notice that the camera view looks a little bit different from normal. That's because I forgot my webcam at school for the first time this year. I knew it was bound to happen eventually, but I'm so mad that I left it at school. I knew I had to record videos today too. So what we have going on is my phone is currently duct taped to the monitor. Don't try this at home, kids. And it is projecting the webcam, the camera from the phone to my computer via my Wi-Fi network. So we're not going to let anything stop us from getting some Algebra 1 done today. I will have my webcam back for next time. But I was like, wow, I got to try this new technology. I should definitely, it's almost comical though. I should definitely post a picture of this. I probably will on Google Classroom along with this video and the practice problems. So in any case, we're not letting it stop us do some algebra today. This is the problem that I actually left off with at the end of last class for period A2 yesterday. I also ended off with it in the video yesterday. My A3 class didn't quite get to it, but this is the problem that we are going to start with today. I would very much like to ask you guys, if you haven't finished this problem from last class, to please try this problem now. Pause the video, take a minute to do it, and unpause when you're all set, and we'll go through it. So hopefully you have done that. You've paused the video, tried it out on your own, see if you can get an answer. This is another elimination problem where we can try to figure out at the very start, since all my variables are lined up as they should be, we can try to figure out which of these I can multiply by, or how I can multiply one of these two equations to make those coefficients match up. And what I would notice here is I'd say, ooh, I don't know about the 5 and 2. There's no real common factors between those. But I do know about the 2 and the negative 6. I can multiply this top equation, if you notice, by 3. And by multiplying the top equation by 3, actually, let me use a red. Will stand out more. Multiplying the top equation by 3, we would be able to get those 6 y's to match up. That would give us here our new top equation. 3 times 5x is 15x. 3 times 2y plus 6y is equal to 3 times 21 is 63. And then I'll leave my bottom equation the same. Negative 2x minus 6y is equal to 2. And now that I've modified that equation, that allows me to use elimination to add these two equations together and eliminate my y variable such that I can solve for x. So what I can do now that we have 6y and negative 6y, we know that 6y plus negative 6y would equal 0y. So we can add these two equations together, right? Notice if we subtracted, we would not get canceling out, right? If I subtracted 6y minus negative 6y, that would be 6y plus 6y, which is 12y. So that indicates to me, ooh, instead of subtracting, I should probably make sure I add. So I'm going to do exactly that. 6y plus negative 6y is 0y. So this right here, this matching piece eliminates, which is great for us. So we're left with 15x plus negative 2x is 13x is equal to 63 plus 2, 65. Now this is just a one-step equation in which I can divide both sides by 13 and get that x is equal to 65 divided by 13, 5. All right. Hopefully that made sense. Now that we know that x is equal to 5, we can use that information to solve for y. We can take that and plug it into any of the previous equations. This one here, this modified version of our first equation, or this original version of our first equation. Regardless of what we pick, it's going to work out just fine. So personally, just to pick an option, I'll take it, I'll plug it into the second equation here. And that would give us, if we do that, that negative 2x, but now we know x is 5, so negative 2 times 5 minus 6y is equal to 2. And now we can just use a little bit of algebra to figure out what y is equal to. So I'm going to do exactly that. Negative 2 times 5 is negative 10 minus 6y is equal to 2. Let's get y by itself by adding 10 to both sides. This is a two-step equation. We should be used to doing this. Negative 6y is equal to 12. Divide both sides now by negative 6. And we would get that y is equal to negative 2. All right. So our solution to this system of equations is that x is equal to 5 and y is equal to negative 2, which you could certainly leave like that if you wanted to, or you could write it as an ordered pair, 5 comma negative 2. Either way, totally fine. All right. Hopefully that made sense. I want to do one more example of a system of equations with you before we get into special cases. You know we have to talk about all real numbers and, infinitely many solutions and no solution, right? We know we have to talk about those two things. We've done it with graphing and substitution already. So before we get into that though, let's do one more example like this just to try and clear up any misconceptions. Ready? Second example of the day. How about something like this? Let's do negative 4x minus 2y is equal to negative 10. And also 8x plus y is equal to negative 1. Let's give that a shot. Again, we kind of ask ourselves, how can I multiply one of these equations such that those variables are going to line up? How can we make that occur? And here, we can make that occur in actually a couple ways. We could either multiply the top equation by 2 to make the negative 8 match up with the positive 8, or we could multiply the bottom equation by 2 to make the 2y match up with the negative 2y. Whichever way you choose to do it is totally fine. Got to adjust the duct taped camera here. Whichever way you choose to do it is totally fine. It's up to you. Personally, just for the sake of picking something, I'll take the top equation and multiply it by 2. But again, I don't want to discourage you. You could certainly take the bottom equation and double it as well to make the y's match up, whatever floats your boat. All right, so if I multiply the top by 2, if I double it, we'll get negative 8x minus 4y is equal to negative 20. Notice how everything doubled there, right? And over here, I would get positive 8x, just staying the same, plus y is equal to negative 1. Now that we see those coefficients matching up, right? We see the negative 8 and the positive 8. Now I can add my equations together. Because negative 8x plus 8x would equal 0x, and it would eliminate, right? Notice we wouldn't subtract at this point, because subtracting would do negative 8x minus 8x would be negative 16x. That's counterproductive. It gets us further away from where we're trying to go, right? So I would add 8x, or I would add the second equation to the first equation. So when we do that, because we see these match up, that's good. That means it's time to eliminate. These are going to go away. We'd see negative 4y plus positive 1y is going to be negative 3y is equal to negative 20 plus negative 1. That's negative 20 minus 1, really, is negative 21. Now, just a one-step equation. Let's divide both sides by negative 3. And we'll get our y equals negative 21 divided by negative 3, positive 7. Okay? Now, very important. The fact that we know that y is equal to positive 7 means we can now take this value, plug it into our equation. Again, it doesn't matter which one, but just for the sake of picking one, I'll do the second one. And solve for x. Again, you can plug it into the second equation, the first equation, which was modified, or even the unmodified version of the first equation. They all have y's in it, so whichever one you want to pick is entirely up to you. You'll get the same answer for x either way. So watch what happens. 7 goes in. We'll say now, using that piece of information, we'll say 8x plus y, which we now know is 7, is equal to negative 1. And now we can just go forth and solve this simple little equation here. 2 steps, subtract 7 from both sides. We would get that 8x is equal to negative 8. Divide both sides by 8, and we'd get a value for x of negative 1. Right? I know I'm kind of flying through those steps, but that's something, a 2-step equation, something we did in September. So it should certainly be familiar at this point. All right. Hopefully no questions about that. So we'd say the solution to our system of equations is -1, 7. All right. Hopefully logical and clear so far with the examples we're seeing here. Let's do our special cases, and then we'll be able to call it a day. All right, but here's some 2 great examples on how to solve by elimination, in addition to the examples we did in class the other day, and in addition to the practice problems and answer key that you have to work with on your own. Okay? Let's do it. Let's do it. Let's do special cases, okay? Let's start with our infinitely many solutions, or our infinite number of solutions. All right, let's start with our infinitely many solutions. Consider a problem like this. Ready? 7x plus 4y is equal to -12, and -14x minus 8y is equal to 24. Okay? Seems like a pretty standard system of equations at the very start. Doesn't seem like there's anything peculiar going on here. So what I would do is I'd look to see, how can I modify one of these equations such that we can get some matching coefficients? And I would notice that, hey, if I take this top equation and multiply it by 2, the 7 will become a 14 and match up with the -14 so that we can then do elimination. So that's exactly where I would start. I would take that top equation and double everything. Right? Sorry, that's kind of written off to the side there, but multiply everything by 2. By doing that, we would get in the top equation 14x plus 8y is equal to -24. And in the bottom equation, we'd get -14x minus 8y, just keeping it the same, is equal to 24. And now is where you might notice the weirdness, right, show up. Didn't seem all that peculiar at first, but now after we modified our equation to match up some coefficients, specifically we tried to match up the coefficients of x, now we notice that not only do the coefficients of x match up, but also the coefficients of y and also the constants. Everything is like overlapping each other. So combining these equations together, if I add the first equation plus the second equation, notice what's going to happen. We would have 14x minus 14x goes away, right? 14x plus -14x. Here I'd have positive 8y plus -8y, also eliminated. So the only thing left on that left-hand side of the equation would be 0 is equal to, right? No x's and no y's, so it's just 0. What happens on the right-hand side? Well, we get -24 plus 24 is also 0. And notice we end with a true statement. That's the stuff we've seen before. Right? 0 is equal to 0, which means that no matter what value you pick for x, and if you pick a matching value for y that's also on the same line, it'll work out no problem. It'll work out no problem. So we'd be able to say here that because all the variables eliminate and we end with a true statement, then this has a solution of, or this has infinitely many solutions. So we say this has an infinite number of solutions, which you can write out, or you can use the shorthand of the infinity symbol to denote that, if you so desire. That's just like we saw with substitution, if you remember. If everything canceled out and we saw that we'd be left with a true statement, then it's an infinite number of solutions. No solution is when we saw that all the variables canceled out and we were left with a false statement. And not surprisingly, the same thing occurs with elimination. Watch. Let's consider this problem. -3x plus 10y is equal to 9. And also -12x plus 40y is equal to 0. Okay. What you may notice right off the top, at least the thing that catches my eye first, is the y's. I see, if I take this top equation and quadruple it, or in other words, multiply it by 4, we would notice that, 10 times 4 would be 40, and then we can eliminate those two equations. So that's exactly what I would do. I'd say we need to modify that top equation by multiplying everything by 4. If we do that, take a look at what we get. We're going to get 4 times negative 3x is negative 12x plus 4 times 10y. 40y is equal to 4 times 9, 36. Bottom equation I'll leave the same. Negative 12x plus 40y is equal to 0. But now we kind of notice the same thing happening that happened with our infinitely many solutions, right? If I go to eliminate, I go to subtract the two equations together, because notice we'd have to do 40 minus 40 to equal 0. We couldn't add them together because 40 plus 40 would equal 80. We don't want to do that. We would subtract the two equations and we'd say negative 12x minus negative 12x, that's negative 12x plus 12x, is 0x. The x's have eliminated. The y's match up too. 40y minus 40y, those also eliminate. And I'd be left with 0 on the left-hand side, because just like the problem above, all of my variables were eliminated. What happens on the right-hand side? 36 minus 0 would just be 36. And we're left with this bunch of lies, right? We're left with this false statement. 0 is not equal to 36. This is a false statement. So that means no matter what variable you picked, or what value rather you picked for the variables x and y, you would never be able to find something that works. You would never be able to find something that works. And so therefore, we'd say because all the variables eliminate and we're left with a false statement, that there is no solution. And you probably noticed that this is very similar to substitution. We saw very similar things happen in substitution. If all the variables eliminated and we were left with a true statement, then there was an infinite number of solutions. If all the variables eliminated and we were left with a false statement, then there was no solution. All right. Just a quick little recap before we wrap things up. So today, to start the class, we did 2 problems. The first of which I asked you to end the last class with, and hopefully you did a great job with that. And if you didn't, hopefully you paused the video, tried it out on your own before we went over it. What we can do is we can again triple the top, multiply the top equation by 3. That makes these y's match up here. And then we can add the two equations together to eliminate, solve our one-step equation, use this information about x to take that, plug it back into our equation, and get y. Right, makes sense, hopefully. The next thing we can do for our second equation, number 2, is double the top to try to make x match up. You could also double the bottom to make y match up as well. You would have actually gotten this first and then this second, but regardless. When you make one of those variables match up, eliminate by adding the two equations together, solve our little one-step equation for y. Then the key part is using that piece of information to say, since we know y is 7, that means that if we take that and plug it in, 8x plus y, which is now 7, equals negative 1. That's a big key part, the elimination and then the plugging back in. And then we just solve our little equation left over. We also took a look at the special cases today. We saw what happens if you have an infinite number of solutions. You'll just get all your variables to eliminate and you'll be left with a true statement. And no solution is when you get all your variables to eliminate and you're left with a false statement. All right. Hopefully that made sense. Thank you so much for your attention and focus today. Like I said, I appreciate you putting up with my bootleg camera setup today. I will take a picture and post it on Classroom because it's really just too hilarious to not take a picture of. But thank you, everyone. And again, nothing's going to stop us from getting Algebra 1 done. Have a fantastic rest of your day, and I'll see you for more practice at the end of the week. Take care.